done with the STT-RAM. And why it is so important, this is a memory hierarchy people are looking at. Nowadays, we have this SRAM, DRAM, slow but cheap, but all have high power consumption. And then further away, we have very slow flash memory, the thumb drive, the hard disk. They are slow, actually considered to be slow. Talking about millisecond of time, right, in the hard disk or hard drive tape is even like talking about seconds to access something. We have two gaps. One is the gap between SRAM and DRAM. This is one memory wall, right? In terms of the cost, this is lower if you go to this direction. In terms of density, this is higher. Okay. Now we hope that we can use STT-RAM, which has a fast speed, long endurance, very close to the SRAM, and even replace SRAM. It will help to bridge this memory wall, this memory gap. Then you save a lot of energy to transport data. This is very important for machine learning, big data, right? Between the DRAM and flash memory, we hope that we can use PCM, resistive memory. They have a higher density than flash memory, right? They also similar to DRAM actually, right? But they are cheap, okay? But most importantly, these are long volatile, right? So this is one of the possible business situation. And that people who try to go into the market is targeting these two regions. And we call this storage class memory. It's not just a memory, it even helps you to store something. I don't have to store all my, 1,000 pictures every year or every month in the flash drive. I put it here, I can read it anytime, very fast, right? You know how long it takes to just copy a 5 GB USB, right? This one will be very fast. So any questions? So I think we finished all the memory, not all, I'm going to discuss 3D LAN, but most of them. If now I want to go to neuromorphic computing, I already spent some time as an introduction in the article of the day today, right? What is neuron? A neuron has three major parts. It has a so-called soma, which is the body. Here, if you have, remember you learned about cell biology in the past, all the mitochondria, all this, I forgot of them, all this nucleus, cell nucleus, all the activity happen here. It has a very long line, and we call it axon. Okay. And the signal is propagated from left to right. And here we call it dendrite. It has many dendrites, it can have thousands. And what happened? It is like this. Between this axon and the dendrite, you look into here. Each dendrite is taking a lot of information from other axons. These are the neuron output from other area, right? I copy from Wiki. Basically, you say that actually we are declining. The best is 3-year-old child, not us, okay? I'm the worst in this class. There are about 1 quadrillion synapses, means 1 quadrillion connection. And you have about 100 billion, right, 86 billion of this neuron in your brain, right? So on average, each of these neurons is talking to 7,000 other neurons, right? So a very complicated system. But I want you to memorize, we have dendrite, cell body, and axon. This is very important, okay? And we see the signal go from here to here. The interconnect is synapse. So actually 4 terms, good to remember, right? This is what we call soma. And then we have this axon. And finally, this gap is called synapse. All the neuromorphic computing, most of them, not all, is actually modeling this gap. Okay, let's see how. So first of all, let's see how the signal propagates. Your neuron by itself already built up some potential because of the difference of the ion concentration. And usually you have the lots of calcium outside and a lot of potassium inside. And because of different electronegativity, by default, it is positive outside and negative inside, right? And then now you see why all this toxic or poisonous stuff that can damage your brain or your response or alcohol. Actually, I don't know about alcohol, but toxic stuff, what they are trying to do is actually damage all this chemistry here, right? Some of them will block the synapse so the signal cannot pass, right? And this is all they try to cure these neuro-related diseases. So in regular situation, you have high potential outside, low potential inside. We do inside minus outside, so the voltage across the membrane is negative, about negative 70 millivolt. But if I have a signal, suddenly I disturb the balance, then we call it potentiation or depolarization. It goes to zero and then becomes positive. And because of this, right, and since I spent too much time today on STT-RAM already, I'm not going to discuss the biology, but basically it triggered different channel here to let the calcium diffuse inside, and then it becomes positive. Once it becomes positive, it will trigger the next one to diffuse, but because when it's too positive, it could to open another channel to cause the calcium to diffuse inside again. So at every point, you have this depolarization and repolarization, and then rest. And that's how you pass the signal. Your axon can be very long. The longest one is from your brain to your toe, right? If you want your toe to move, it takes maybe 1 second, I don't know. It's about 2 meter long neuron. This is the slowest response, right? So if you try to burn your finger, you can withdraw very fast. But if you bring your toe, probably you got burned before you can withdraw, right? So this is how it works, right? That's the potentiation I talk about. If you're interested, take a look when you go home. But basically, it is just telling you how this depolarization can keep propagating. Because once the potential energy change, you have this channel, you just keep letting the calcium and potassium going up and down, right? So now you know why your parents keep asking you to eat healthy food, right? If you don't have potassium or calcium, you won't be smart because your neuron will not work. Okay, so that is the propagation. But when I go from one place to another, this is the end of axon of what we call presynaptic neuron. Okay? Because this is just the end of the neuron before the synapse. This is called synapse, right? Basically, it's just a gap. Of course, a lot of chemistry going on there. And of course, this is the dendrite of the post-synaptic neuron. Okay? So what does it do? Once those potential I mentioned here eventually travel to the end, it's going to make this so-called neurotransmitter to fuse with the wall, and then they will release this the synaptic vesicle fuse with the wall, and then the neurotransmitter will come here. And then they will bind with this receptor. They have several function. One is that they might activate the next neuron so that you have a pulse generator. Or they actually have so-called depression, prevent it from activating. This is only one synapse. Remember, it is connect. It have many dendrites. It connect to 7,000 other synapses. So some of them is called inhibiting, right? Some of them are doing the potentiation. So competing with each other. And that is how your brain learns, right? My analogy is not that good, but basically it's like you find what make you to decide that when your hand is hot, get something hot, you will withdraw. Definitely, we keep learning. The first time we feel very painful, we withdraw, right? But later, you might also learn that when I withdraw, I should not withdraw directly. That may hit my face, right? So this neuron coming from different direction gradually build up the correct response, so that the neuron that asks me to withdraw and hit my face gradually will actually inhibit the withdrawal action. But the neuron that is sensing the heat will definitely becomes very strong, so that I can withdraw very quickly once I feel the heat, right? So this is a learning process. The process is the process to, a learning process is the process to modulate the connectivity inside this synapse between different neurons. For some neuron, gradually, you don't respond to their input. There's a neuron, right? Keep asking you to fire. That is what we call fire. You don't do that because you learned enough already. I should not do that. For some neuron, it tells you to fire. It's so conductive because you have a lot of experience. If I don't withdraw now, I'm going to get a lot of pain, right? So this is one basic concept. Any questions so far? Maybe I'm too fast. Right, just a general picture. We are not talking about device first yet. We're talking about just the biology, right? But the most important thing is the synapse, right? Now, there's another term we're going to use. It's called spike timing dependence plasticity, right? So it is like